This meeting is being recorded.
Yeah, multiple features we can run in parallel, right? Or we can do
Yeah.
many things in parallel. Don't need to depend on manual work and
Okay.
everything, all those things.
Thanks, Shant. Thanks for the confirmation. Very nice to hear you about that. Hear from you about that. Okay. So we discussed Docker is an application. Okay. So it is just a application in which you will run the containers. Okay. So how you are going to run the containers and what is meant by a container? So container is the main component of your entire Docker. So you might have a Docker application. For example, if you open a Google browser, so it's just a browser. In the browser, you will type google.com. A tab will be opened. And when you go for the aws.com, for example, it is just a Google Chrome browser. Until now, we are not doing anything. We are not browsing. We are not surfing anything. We are not doing anything. But now, when I type google.com, what is happening here? It is taking us to the search engine called as Google. For example, if I take a new tab and type amazon.com, it is taking me to the Amazon website. For example, if I take portal.azure.com, it will redirect me to the Azure. So now if you can see here, basically Chrome is just an application. But inside the Chrome, we are opening multiple processes. In each and every process, we are running multiple applications. In the same fashion, when you see the Docker is just an application. It is not going to do anything. So where this Docker is installed, so there will be server hardware. On the top of the server hardware, you will be having the operating system. On the top of the operating system, you will be installing the Docker engine. So there are three layers. Okay, so what is this? The starting layer is hardware components, like you will have the CPU, you will have the RAM and all the things, right? So there will be hardware. On the top of that, you will be having the host operating system, host OS. It is like Windows OS or else Linux, any kind of OS. So for example, you can take Ubuntu or HCL like that. You will be having any kind of operating system will be available. On the top of that, what we are doing, we are installing the Docker engine. So it's just like an application. It is just another application like Chrome or else if you take any another application which is installed in your operating system. So now what this application is going to do, just like we are opening tabs, we are opening multiple tabs in the Chrome. In the same manner, I want to run multiple applications. So to run the application, we need to create an environment. And that environment or else process is called as a container. Now, when you see on the Docker, what we are doing, we are creating a container. So inside this container, you will have the environment to run the application. So inside the container, what you are going to do, you will be installing the dependency, application dependencies. Okay, for example, I want to run a Java application. So for precisely, I want to run Java 17 application. So I will install Java 17. On the top of that, I will run the application. I'm going to run that particular application. Okay. So this application can be exposed on a port number, something like 5600 or else 7600, any port number, this application will be running out. So in the same fashion, when you see here, I am going to run one more container. I am going to run another container in the on the Docker application. So whatever the Docker is there on the same Docker application, I'm going to run one more container. And this container, whatever the container that you are seeing, for example, I want to run a Python application. So on the container, what I am doing, I am installing a Python runtime. On top of that, we can run the Python application. For example, if you want to run something like another Java version, for example, I want to run one more Java application, but this time it is like Java 11. Okay, but this time it is like Java 11. So we are going to install the dependency called as Java 11, and then we can run that particular application. So if we can see, so where these applications are running inside a process or else inside a container. This container will have the dependencies to run that particular application. Now where this container is running, container is running in the Docker, or else container is running on the Docker. Where this Docker is running? Docker is running in the operating system. So how containers are getting the resources? For example, if you want to run the application, definitely what is your requirement? You need to have CPU, you need to get the RAM. So now what is going to happen here is, so this application will, or else the container will request the Docker for the requested amount of CPU and RAM. So then Docker will request the host operating system like your Windows or Linux, and the host operating system will communicate with the hardware and provides the necessary resources for the applications to run. So this is how your applications will get the necessary resources. Okay. So now what is the main difference? So this is what the Docker. So if you see the reverse engineering process, so we are going with the reverse engineering process. This is how your Docker works. But before Docker, what is there? Before Docker, what we used to have? Basically, in the first stages, when you go backwards to somewhere like 2005 or else 1995, 1999, at that time, we used to have only physical servers to run the application. There are certain physical servers which are helpful for us to run the application. So these physical servers will have the, whatever the physical servers you are watching, the physical servers will have the hardware and like some CPU and RAM will be there. On the top of the server, what I'm going to do directly, I'm going to install the operating system. Okay, there will be Linux operating system or else Windows operating system, anyone. So let us say Linux operating system, especially RHL I have installed. On the top of that, what I can do here, I want to run my application. So if I want to run the application, first of all, I need to install the dependencies. So I will install the dependency. For example, I want to run the Java application. I will install the dependency called as Java. For example, it is Java 11. At that point of time, for example, we are having Java 8. I am installing Java 8 on that particular operating system. On the top of that, what I can do, I can directly run my application. This is what going to happen in the good old days. If you go for the olden days like 1999 and 2000, this is how we are running. So now the application is running fine. We don't have any problem. But the point is, for example, there is a developer who is working on the same application. Or else there is a developer, he got a new project. Okay, as per the project requirement, he has to create an application on Java version 11. So the project requirement says that you need to run on Java 11. So what is the main problem here? Already, what is the version, which version of Java is running on this server? On this server, we are running the version called as Java 8. If he creates a, or else if he develops an application on the Java version 11, now you tell me whether the compatibility will be there, whether the application will be running. Is this application will be running on this server, whatever the old servers that we are having?
No, there is a definitely compatibility issue. Java 8 depends
Compat
on the
yeah.
11.
Compatibility issues will be there. So to overcome this compatibility issue, what we have to do, again, we need to purchase one more server. Already we have a server running. Okay. So then what we have to do here, again, we need to purchase one more server. So if I purchase one more server, try to understand what will be the cost of that particular server. So the cost of the server is very high. So I cannot put that budget. If I am a topmost MNC company, then we can say that. But if you are a startup company, is it possible for you to invest multiple servers? And not only that, if you see here, one physical server you will get with some 16 CPU and somewhere like some 128 GB of RAM. Minimum RAM I'm talking, 128 GB of RAM. So your application only runs for your application will only consume maximum of 4 CPU. For example, I'm taking 4 CPU, some 32 GB of RAM. What about the rest of resources? In the peak load time also, your application is going to consume only 4 CPU, 32 GB of RAM. What about the rest of the resources? They are wasted. Or else we can run one more application in a different platform. For example, I can install one more platform called as Python platform. I can run that application, but okay, this Python application may consume the entire resources. There is a chance, or else your Java application may consume the entire resources because of there is a concept called as memory heap. You know about the memory heap, right? Memory heap. Do you know that?
Yes, yes.
What is meant by memory heap? Consuming the lots of RAM. Okay, when the application is running, if there is any bugs in the application, if it consumes lots of RAM, then that is called as a memory heap. Correct me if I am wrong. I am not into the development. I am into the DevOps. So I am just requesting you. If I am wrong, just correct me. Okay, so this Java application will be consuming lot of resources. To overcome this problem, what we have to do, if I run another application like Python application on the same server, the resources may not be sufficient because of the overconsumption of the resources by your Java application, or this Python application may run on that, or else if you think we can run the database. So unfortunately, you will run one more database, for example, on the same server to do the cost savings. This database may consume a lot of resources, so we cannot do that. So this is the main problem with the single server, whatever the single server that we have created. So now what they are doing, what is happening here means, I don't want to make other application affected for this. Okay, for that reason, what we have created here is not only for less consumption of resources or else heavy consumption of resources, all these things are happening. So for that reason, we are going for a concept called as virtualization. So there is a concept called as virtualization. Okay. So if you can see what is going to happen on the virtualization, look at that. Look at that. So there will be server hardware. On the top of that, we can install an host OS, or else directly we can run the virtual machines also. So now if you install the virtualization software, then that is called as a bare metal virtualization. If you install an operating system on the top of that, if you install the virtual machines or else virtualization software, then that is called as a hosted virtualization. Right now, I am having the hardware. On the top of that, I am installing the virtualization like VMware, okay, VMware or VMware ESXi. Okay, on the top of that, what I can do, I can create a virtual machine. So what is this virtual machine? Let me give a small example. For example, you are having a hard disk. Hard disk is there, or else SSD is there. So if you want to divide that hard disk into multiple partitions, are you going to break the hard disk into physical, like physically you are going to break the hard disk, or else logically you are going to divide the partitions inside the hard disk? How you are going to do that? Again,
Yeah, definitely logically only. You cannot break out.
logic. Yeah, if you break it, then the hard disk will be lost,
Yeah.
right? So you cannot do that. In the same manner, whatever the hardware that you are having, with the help of virtualization, what you are going to do, you are going to logically divide that hardware into small virtual machines. Those are called as VMs. So this virtual machines, on the top of the virtual machines, what you can do, you can install an operating system that is called as guest operating system. That is called as guest operating system. So for example, if you want to run the Ubuntu, okay, I'll make it as guest OS. If you want to run Ubuntu, you can install Ubuntu. If you want to run RHEL, you can install RHEL. If you want to run Windows, you can install the Windows. Just like your EC2 instances. EC2 instances are the virtual machines. And then your Azure virtual machines, they are the name itself says that they are virtual machines. Okay, so whatever the servers that you are seeing in AWS and Azure, there are totally virtual machines itself. So on the top of the VM, we are going to install the guest OS. On the top of guest OS, what we are going to do, we will be installing the dependencies. We are going to install the dependencies, either it might be Java or Python, any dependencies. And then on the top of that, what we can do, we can run our application. So this is what happens with the VM, virtual machines. Now, what is the main problem here? So if you see in the first one, you are having a problem called as physical resources misconsumption or else misusage. Okay, to overcome this problem, what we are doing, we want that physical resources to be streamlined. And for example, if there is a Java application running in this virtual machine, so then the Java application will consume the resources provided to this virtual machine. So if it is consumed beyond the resources, then virtual machine will move into the hang state and it will shut down. So only that application will be affected. For example, if I am running a Python application beside this, if I am creating one more virtual machine, I am running a Python application here. Then what happens? Then this VM2 will be running safely. We don't have any problem with the Python application. The main problem with the physical servers is this. Okay, so to overcome this problem, we have invented the virtualization. And for example, on besides of this, there will be an Windows operating system or else Windows virtual machine where it is going to run the .NET kind of applications. So those applications will not be affected. So these are the applications which are running inside the physical hardware, single physical hardware, but they are isolated in nature. One virtual machine will not impact the another virtual machines, or else one application will not impact the another application which is running on two different virtual machines. So this is the main use case of the virtualization. Then we are having virtualization sorted, right? Whatever the problems that we are having with the physical servers, those are sorted by the virtual machines. Then why we need to go for the Docker? So the main reason why we are going for the Docker is for the virtualization. Whatever the virtual machines that you are seeing, virtual machines are very slow. They are heavy weighted. Okay, so to shift from one location to the another location, or else to move from one location to the another location, or to pack that virtual machine and send the virtual machine from one environment to the another environment. For example, you are running this virtual machine in the development environment. So you want to run the same virtual machine in the production environment. So then to pack that virtual machine, it is going to take a lot of space. So it is heavy weighted. To overcome this problem, what we are going to do here is we are going with for a lightweight concept called as containers. So these containers are very tiny and they are portable. So why they are portable? So if you see here, this virtual machines, in the virtual machines, we are going to install the guest operating system. Guest OS will be installed. So it is going to install all the dependencies, whatever it requires, every utility will be installed, every scrap will be there, whatever not necessary for the application also getting installed. So because of that, what is going to happen? The size of this particular virtual machine will be very high, and the operating system will be installed. Directly the operating system will be installed, drivers will be installed. These are all not necessary for us, but still they are getting installed. To run the application, we don't want all this. So by removing all this, what we are going to happen, we are getting the containers. Containers are very lightweighted in nature, where you will have only the application and its dependency. So now, if you can see this application will consume the resources from this virtual machines. So the virtual machines will be provided with certain amount of resources from the hardware with the help of VMware. Okay, with the help of VMware, the hardware will provide the resources to your virtual machine. So the application will consume the resources only provided to this virtual machine. So this is how the communication will happen. But when you come to the containers, whenever you come to the containers, in the containers are also in the isolated environment itself. Whatever the containers that you are seeing, these are also in the isolated environment, just like your virtual machines. So here, what is going to happen? This particular application will communicate with the container or else directly with the Docker for the resources. The application will communicate with the Docker saying that I want this much amount of resource. Docker will communicate with the host operating system. In the host operating system, you will have the kernel, and the kernel will communicate with the hardware and provides the resources towards your application. So the same thing will happen, but this is all happens within the operating system. But if you can see, these are the different virtual machines that are running, and these are running the multiple applications. So the main difference is if you want to pack this, So it is going to be very heavy. When you pack the containers, in the containers, we don't have the operating system installed. We don't have the unwanted utilities. We don't have any kind of drivers. Okay, nothing. Only the application and its dependencies will be run. So that's the reason we are going with the containers for portability. So I want to make sure that the container will be available in each and every environment within minutes. So that can be happened with the help of Docker. So that's why we are going with a concept called as Docker. And this Docker is also known as software virtualization. Whatever the Docker that we are learning right now, this is called as software virtualization. And if you can say, this is called as hardware virtualization. Whatever the VMware ESXi that you are seeing, that's a hardware virtualization. This is the main difference between why we are having the physical servers, and then why we have went for the virtual machines. Now why we are going for the Docker. And not only that, suddenly if you want to increase the multiple number of containers, within seconds you can increase the multiple number of containers. That is called as scalability. If you want to increase the virtual machine, of course you can increase the multiple number of virtual machines, but it is going to take some time. Okay, comparing to the virtual containers, virtual machines take some time to scale up. But when you come to the containers, containers are very lightweighted. Within seconds, they are going to scale up. Kubernetes is going to do the same. So the auto scaling will be there with the Kubernetes. Okay, Kubernetes will manage the containers and it will increase the number of containers whenever there is a bottleneck situation is there. Whenever huge amount of traffic is hitting your containers, automatically it is going to increase the containers. Now, if the traffic is very, very less, automatically it is going to decrease the number of containers. So that is the main use case where we are going to use this particular containers and who will manage the containers. Any questions here up to now? Do you understand completely? Any questions? Whatever we have discussed, do you understand it? Any questions?
Yeah, I think we got it. I got it.
Yeah. Rest of the people who are attending to the session, can you please tell me whether you understood or not?
Yeah, I understood. You can continue.
Yeah. Jabesh, this is the first session you are attending, or else in the previous classes you are there?
No. Actually, today I joined first session.
Oh, sorry, I have another student with the same name. That's why I'm asking.
Okay.
Yeah, thanks for that confirmation. Okay, so this is about the entire concept of your virtualization and containerization. Now, what we will do here is, let me show you how fastly I can move the containers, and how fastly I can deploy the containers in the servers. Okay, so let me show you that. Give me a second. Sorry, guys. So now let us see. For example, you are there are so many Java developers. Tabesh, are you a Java developer? Or else are you a developer? What is your background?
No. I am a web developer using Python, Django, API class, everything.
Django.
Yeah.
Very nice to hear about that. Okay, so I'll get back to that. But before I go into the main concept, let me show you a small application. So it's not a very big application, it's just a microservice which I have created. Let me check that. 1 second. Okay, it is not here. Let me do one thing. So as a developer, what you are going to do when you write the code, where you are going to push the code into the GitHub, or else into the Bitbucket, or else into the GitLab, whatever you are using, whatever the company you are working, whichever the versioning tool that the company is using, right? So right now, for example, I am having the GitHub. So in the GitHub, what I am having here is I am having a Java application. So this is my Java application, which is of a single microservice. I don't have multiple microservices. It's just a small application which I am running. For this Java application, I am having pom.xml. Okay. So now these are the two requirements to run this application. Okay. So now what I will do, I will download this particular zip file. Okay. Then I will extract this. Okay. Here, what I can show you here is this is the Java multi-stage developer application which I am having. Here you can see we are having the source code. Okay, this is the Java resources. Inside this, I am having the application.properties file is also available, on which the server is the application should be running on the port number 5600, or else I can make it as 7600 also. Okay, this is my requirement. Now what I want to do here is I want to create an image. So with the image I can run the container. So how I can create the image over here? Let me do one thing. I will copy this folder and put it into, let me do that. I will put it over here. Okay. So here let me open the command line or else PowerShell. Okay. So I think I have the Maven installed on my system. No problem. So let me build the application. So it's an Java related application, and here you can see there is a pom.xml. I will show you what is this pom.xml. It is going to declare this whatever the dependencies that your application need. Everything we are going to declare in the pom.xml, and what is the supported Java version, that is Java 11, and everything is there. Okay. So now what I will do here is I will run this Docker file. So we have a Docker file created. Let me go back to this. I'm going to create an image over here. So, but the Docker is not running on my system. Okay, it is running. That's fine. Okay, so here you can see I installed the Docker desktop in my Windows system. So whenever you are having Docker desktop in the Windows system, whatever the commands that we are using in the Linux, the same commands you can use in the Windows. So we are communicating with the Docker. It is not about Windows commands or else Linux commands. These are the Docker commands. Anywhere they are the same. In the Mac also. Okay, so now Docker build -t Java colon or else Java count app. I will simply name it as count app version 1 and dot or -f multi-stage dot. So I will tell you about this, but what is the problem that I'm getting? The system cannot find the file specified. Multi-stage Docker file is there, no? Okay, let me do one thing. Docker engine is running or not? Let me check out that. Docker PS. Yeah, the Docker engine is not running. That's why. Let me do one thing. I will start this Docker desktop. Okay. So I will tell you what happened in the Docker architecture. But as of now, I started my Docker in my system, in my computer, or else in my laptop. Now what I will do, I'll go back here. Docker PS. Okay, we have the Docker running right now. Docker build -t count app. So this is the image which I am building. Okay, with this image, what I can do, I can create my container. Inside the container, the application will be running. What is the server port number that I have given? 7600, right? Hold on. It's going to take some time. Just hold on, guys. Which means I just want to show you the demo, how the containers will be, or else how the images will be quickly transferred to the other servers, and how we are going to run the application within fraction of seconds. Okay. Okay, so we have the Docker images. We have the images available, count app version 1. So let me run the container, Docker run -itd. I will tell you about each and every command. Don't worry. -name container Java. Okay, this is the name of the container, -p 7600 colon 7600, and the image name is count app version 1. So that is what the image name is, right? Count app version 1. So now the application will be running. So if you can see here on 7600, it is running localhost 7600. So if you can see, I got my application. Okay, this is a simple application which is running with a single microservice. Now we have the image in our system. Now I want to push this image into my Docker hub, hub.docker.com. I will tell you in detail when you go into the concept, but as of now, I'm just logging into my Docker hub registry. Just give me a second. Okay, let me push this particular image. Docker login -u Chaitanya Manikumar. So I want to log in into my Docker hub. I want to log in into the Docker hub. I'm doing that. Password is okay. I just logged into my Docker hub. Let me push the, or else first of all, we need to rename this image. Why we need to rename this, everything I will tell you. But as of now, just concentrate on how I am pushing and how I am accessing the server, how I am deploying that particular application on the server. So Docker login or else Docker tag -t. What is the image name? Count app version 1 to Chaitanya Manikumar / count app version 1. Okay. So now if you can see Docker images, we have the new image will be created. Chaitanya Manikumar / count app version 1. Now what I will do, I will push that particular image. Docker push count app version 1. So here you can see the image will be instantly available in my Docker hub. This is a global registry in which you will have the images are available. There are so many images that are available. So I'm going to just show you about this. So hold on. Okay, now the image has been pushed into my Docker hub. If you can see here, we have the count app version 1 just came into my Docker hub. Now what I will do here is I will log in into my AWS account. Inside the AWS account, let me log in into this. I already have my Docker server running. Okay, I already have my Docker server running. So now what I will do here is, okay, instances. I'm in Asia Pacific. Let me go to the North Virginia location. I will explain you how this matters. Okay, so what we have done and what is happening over here. Let me go to start the instance. Okay, this is the Docker server which I'm having right now. Let me log on to that server first. Now, if you can see, what is this happening over here? You have to tell me as a developers, you have to tell me. You are the developer. Just assume that you are in an office. You are working in your office. Now, what you have done, you have developed an application. You have developed an application in the Java language, just a microservice, or else Python language, any another language, whichever you are familiar with. Now, what you will do, you will push the code into GitHub. You will push the code into particular Git version, or else it might be any version control. Either it might be GitHub, or else it might be what I can say. It's a centralized version control, GitHub, Bitbucket, GitLab, like that. So here, just imagine from where I have pulled the code from the GitHub. So imagine that you are the developer, you have pushed the code into the GitHub. Now as a DevOps engineer, what I have done, I pulled that code into my local computer, or else I can pull the code directly onto the server. And then what I will do, I will install or else I will create a Docker image from that code, whatever the code that you are having. So I'm going to create a Docker image. So here you will have the Docker installed and Docker image will be generated. Once the Docker image is generated, what I have done, I created a container which is running on the port number 7600. Okay, so inside the container you have an application that is running on the port number 7600. Now I can give that access to each and everyone across the world. Container on port number 7600. Now let me show you, is the Docker server is up. Okay, I will tell you about how to access the server also in the next session, but as of now, just to concentrate on what I am doing. Sudo su hyphen. Let me check Docker is available. Yeah, Docker is available. Let me pull the Docker pull. What is the image name which is pushed into the Docker hub? This is the image. Okay, so I'm going to pull that image version 1. Okay, so here you can see Docker images. Okay, we have Chaitanya Manikumar count app version 1. So let me run the container. Docker run -itd -name Java container -p somewhere like 7600. What is this 7600? It's a port number. So why we are giving 2 times, I will tell you. So one is the server port and the other one is the container port. So if I say right now, it might be confusing for you. So Chaitanya Manikumar count app version 1. Okay, already Java container is running. So let me do one thing. Create Java container 2. So here you can see Docker PS, we have the Java container 2 will be running on the port number 7600. If I try to access the application from the server, let me copy the server IP on the port number 7600. Here you can see we are able to access the application. I will provide this URL in your chat box. Try to access the URL and tell me, are you able to access that application or not? One second. Check out that I have given in your chat box. Try to access the code and I will do one thing. http:// yeah, I gave you the URL. Just try to access that particular URL and tell me, are you able to access the application?
Yes, yes, we can see.
Yeah. So which means that either you might be in the mobile, okay, either you might be on the laptop, you are able to access the application. Now try to understand the concept here. So for example, you are a developer, you have sent the code into GitHub, and I am right now sitting in Hyderabad. Okay, I am right now sitting in Hyderabad. I created a Docker image and pushed the Docker image into my Docker hub. From the Docker hub in the server, what I am doing, I have a Docker installed on the server. Automatically, I pull that entire image from the Docker hub and I created the container inside the server and gave the access to you. Okay, so now what you are doing, you are able to access the application. See how simple it has been. Okay, but when you go back to the previous eras, like 2015, 2010, 2005, at that particular time, it is very difficult for you to deploy the application. Most of the applications are monolithic application. So now whenever you see here, we are having microservice based applications. But previously we used to have monolithic applications. Okay, what is the main difference between monolithic and microservices? Monolithic means the entire application of whatever the modules. For example, let me take a very simple example. Have you ever ride the Uber or Rapido or else any application? Have you ever hired a taxi from Uber? Uber guys, yes or no? You understand my question?
Yeah, yeah, yes.
Uh,
We listen many times. Yeah.
when you open the application, see if it is a monolithic application. If it is a monolithic application in the sense, see what are the different modules will be there in the Uber. Anybody can tell about this? There will be user management module, okay, and driver management module, and then notification module, notification management I will call it as, and then what you will have? You will have the payment module, payment management module, and ride information module. That will be in the or else ride management module. I will call it as ride management module. So these are the different modules that you are having. Now, whenever you are working with the monolithic application, so the entire modules will be in a single app, will be in the single application. If there is a problem with the notification management module, for example, this particular notification module, you find out a bug. So you want to rectify that bug and you want to take down the notification module down, or else notification whatever the service you are having, you want to take down that particular service. But what happens in the monolithic application? So everything will comes under a single application. Now what you have to do, you have to take down the entire application. Just like, for example, in the good olden days, we used to have the families, like very big families are there. Okay, very big families will be there in a single home. Okay, if there is a problem for a single parents or a single family, all the families, either it might be your parents, your great parents, or else your uncles, aunts, and everyone will be in a single home. If there is a problem for a single person, entire family will suffer for that. Okay, everyone will feel sorrow about that, and everyone will be participating into that. It's a good situation, it's a good scenario, but if you see, everyone will be involved into that. Okay, but now when you see right now, so it has been, the families has been into the micro families. So your aunt and uncle will be residing in some location, you will be residing in some location, you and your parents will be residing in some location, and your some another auntie and uncle will be residing in some another location, your grandparents will be some. So this is what diversifying the entire family. Now, if there is a problem for your for one of the family, only they will suffer about that. So it is not a good scenario. But when you take this particular example, it's not a very good scenario. But this is the case. They will only suffer. But everyone are into a single family. Then if any one of your family suffers, everyone will be feeling sad about that. The same will be applying over here. For example, you are having user management, driver management, notification, everything under a single application. If one application is down, then, or else if one service is down, then automatically or else the entire application will be into the down state. Okay, that will not be able to access by any user. So when the microservices came into the picture, everything is into a small microservice, or a small service. So user management will be there. It will have its own database. The user management will have its own database. Driver management will have its own database, and notification management will have its own database. Like that, we are dividing the single mic, or else the entire application into simple microservices, so that if there is a problem with this notification management service, only that particular area will be affected. The entire application will be running properly on. So within an hour, you can make that available. You can make that application available for the end customers. That you can do about that. So this is the main benefit of microservices. So the main reason beyond this microservices is Docker. So you are having the user management service. This user management service can communicate with another container. There is another container which is having the driver management service. So these two will be in a network. So these two containers will communicate with each other. Whatever the data that is transmitted from one container to the another container, we can transfer about that. So this is the main concept of your microservices. So Docker is very helpful for you to provide the microservices architecture, and these microservices are managed by the Kubernetes. Now, do you understand what is the microservices and monolithic architecture? Any questions here? Questions? All right. So tomorrow I will start installing the Docker. Okay, tomorrow I will start installing the Docker on my Ubuntu machine, and I will tell you about how to run the Docker, what is Docker networking, and all the kind of stuff. And from Monday onwards, you will have the paid link. You have to pay for this course, and then you have to join into the course. Then we will continue the course. Okay. So that's it from my end. If you have any questions, you can ask me. And I will just disclose one more thing. I did not say about my name. So those who has entered newly, I just want to tell you about myself. I am Chaitanya. I am having 13 years of experience into the trainings. Previously, I trained my students on networking, and then servers, Red Hat Linux, AWS, DevOps, and also now we are continuing with the Docker and Kubernetes. And I am a DevSecOps engineer, level 5 consultant in a topmost MNC company. And yeah, I'm having a certification of I'm a certified Kubernetes administrator. I'm an AWS Solution Architect Associate. Okay, that is my certification. I am a Red Hat certified administrator. I have my Microsoft certification. I'm a Microsoft professional. So these are the different certifications that I am having. And yeah, so the course duration will be somewhere like 20 to 25 days. Okay, 20 to 25 days. Within 25 days, we will try to complete the entire course. And then evening 6 p.m. to 7:30, 8 p.m. You will be having the sessions. 7:30 or 8 p.m. And what else I am missing? You are going to get the videos and documents related to documents for each and every session. You are going to get them.
It's starting time is 7 o'clock, na? Started?
No. Now it is demo, so it is 7 o'clock, but actual class sessions will be at 6 p.m.
Okay.
So every day recording will get on the same day. Let's say, for example, sometimes we are in between some meetings, right?
Yeah, sometimes it might be delayed. Okay, but every day you are going to get on time itself. Most of the times you will get it up. Okay. If you don't get any videos, just let me know. I will talk to the DURGASOFT. Why? Because they are the video providers. Okay.
Yeah.
Okay, guys. I hope I made it very clear for you. If you have any further questions, you can ask. Okay, fine then. Have a nice day.
Thank you.
Thank you. Tomorrow also same time at 7 o'clock, and from Monday
Okay.
onwards it will be at 6 o'clock. Okay.
Oh,
Have a nice day and
thank you.
bye bye. Thank
Bye-bye.
you.